Okay, in our second lesson for conics, we're going to be writing and graphing equations of ellipses. So we're going to need that piece of paper again where we could put our equations and formulas for ellipses, unless you printed out the one that has them on there already. But let's talk about it. All right, ellipse is that oval shape there. So Kepler was one of the first ones that said that the orbits of the planets with the sun actually make an ellipse. All right, so we have two types of ellipses, a horizontal versus a vertical ellipse. So here's our horizontal ellipse, meaning that the bigger major axis is stretched horizontally along the x-axis. We have more than one vertex here. We have two of them. We have two co-vertexes to make that oval shape. And we also have two foci there that are inside where the vertex are. So it's basically two parabolas together, right? That include two foci, two vertices, and then the co-vertex. I have the equation here, the general equation for a horizontal ellipse. It's a little different. It's got fractions in there. X minus h squared over a squared, y minus k squared over b squared to equal 1. So ellipses equations always have to equal 1. We have our center as usual, h comma k. We have our vertex now is two of them, so we have h plus a comma k and h minus a comma k. And the same thing for the co-vertex, we have two of them. So we have h comma k plus b or h comma k minus b. And same concept with focus. So how am I getting this A, B, and C thing? Well, the A distance, and I have it in purple, is from the center to the vertex. That's your A distance, so you would be counting boxes for that. To get the B distance, it would be from the center to the co-vertex. Count the boxes for that. And then the C distance is from the center to the focus, so that's real important there. Sometimes, usually, they don't give you all three of these, so you need to use this lovely formula. Almost looks like the Pythagorean theorem. I could go through and explain why, but I think you guys would get bored. But they are using right triangles here. We have a squared minus b squared to equal c squared here. One of the other most important things is that when you set up this equation, whichever bottom number is greater, that's telling us which way the ellipse is going. So the a value must go first, whatever that is. That's the biggest one for ellipses. Okay. Vertical ellipses, it's stretched on that y-axis there. Pretty much the same stuff there. Again, your A distance is from the center to the vertices, your B distance center to co-vertices, and your C distance is center to focus. The only difference here is this equation. What comes first here is the y, because it's stretched longer on the y-axis, so that's why the a squared is first there, plus x minus h squared over b squared equals 1. And again, we're going to use that same formula if something is missing. A squared minus b squared equals c squared. All right, here's our first example. Find an equation of an ellipse with the center as the origin, one focus at 3, 0, and the vertex is at negative 4, 0. So I already have kind of everything done here, but let's kind of talk about it. I decided to graph mine right away, the 3 points. So I got my center in the red. I graphed my focus 3, 0. So I knew that was my C distance right away. So C was 3. And I graphed the vertex, which is on the other side, which was negative 4, 0. And I know that distance is 4 also, is the A, which I have over here. So I am using my formula because I need to know what B is here for this equation here, because I have H and K. I have the A distance. I need to know what B is. So I'm using the formula A squared minus B squared equals C squared. I'm plugging in the 4, plugging in the 3 that I got for the C. 16 minus B squared equals 9. 16 minus what is going to give me 9? Well, that's 7. And my distance for B, root 7, I put that in the calculator, is about 2.6. So I went up 2.6 boxes for B and down 2.6 boxes for B. So when I plug in all my information in this equation here, I'm getting x minus 0, right, because that's the origin, squared over 16. That was my A squared. Plus y minus 0 squared over b squared, which we got, which was 7, to equal 1. So there was my equation for that ellipse. Try another one. Find an equation for an ellipse. The center is 2, negative 3. H and K, that is. My focus is 3, negative 3, and the vertex is at 5, negative 3. Okay, so here in red, here's my center. I also plotted the focus, which is right there. So I already know that my C distance here is 1. I plotted my vertex 5, negative 3. There it is. And so I know from my center to that vertex is a distance of 3. So I have my A and I have my C again. I need to figure out the B. So again, I use my A squared minus B squared equals C squared. 3 squared minus B squared equals 1 squared. So 9 minus what is going to give me 1? That would be 8. So B squared is 8. And the square root of 8 is about 2.8. So I went up 2.8 boxes from the center and down 2.8 boxes from the center and plotted it. This is kind of off a little bit right here. Should be more over this way. My picture's not that great. And I know it's again going horizontally. So I am using my x minus a squared over a squared. So on this one here, my a squared is 9. And then my y plus 3, right? Because it's minus 3, negative 3. And the b squared is, what do we get? 8 to equal 1. So there's the equation for this ellipse. All right. We're going to do a completing the square question with an ellipse now. Okay, so it says find the center, foci, and vertices of an ellipse. Now, how is this one different than completing the square for the parabola? Well, you should notice now we have x's and y squareds. So if we have both x squared and y squared, both of them are squared, we want to keep the x's and the y's on the left. So if we only had one of them squared, we would then keep that one on the left, and then whatever wasn't squared, we would move that over to the right. That was what the big difference with the parabola. So we're going to keep the x squareds and the y squareds on the left. If there is a number, we're going to move it to the right side. So I kept and organized 4x squared minus 8x, y squared plus 4y on the left. And what did I move over to the right was this 4, so that became negative 4. I'm going to do the same process that I did before, but I want to factor so that I have a positive 1x squared and a positive 1y squared. If you notice here, I do not have that. I have a 4 in front of the x squared, so I need to pull that out first before I do completing the square. So I'm going by GCF here. I'm pulling out a 4, and I'm left with x squared minus 2x. This one was good because it was already imaginary 1, so I didn't need to factor that right now. So I'm rewriting everything, coming down. Now I need to complete the square. So for this one here, my b is negative 2, divided in half, squared, gives me 1, so I'm putting 1 there. Completing the square for this one here, my b is 4, divided in half, squared is 4, so I'm adding 4 on the left. Now if you notice here, I'm not going to add 1 on the right-hand side because of the 4 on the outside. I actually need to add 4 times the 1 because it's factored out. I need to consider that when I'm balancing my equation on the right-hand side. So this one here has to be 4, and then the blue 4, that's the usual one because it's only an imaginary 1 there. All right, once we have that done, then we go ahead and factor our trinomial, x minus 1, x minus 1. Y plus 2, y plus 2, that should be. So when I condense it, I have my 4 coming down, x minus 1 squared. I have 2y plus 2, so it's y plus 2 squared equals 4. This pretty much looks like an ellipse, except it has to equal 1. So how do I make this equal to 1? I'm going to divide by 4 here. And I'm going to divide by 4 in every single spot there. So when I divide by 4, I am getting x minus 1 squared over 1 plus y plus 2 squared over 4 to equal 1. What really should come first is this one, right? Because this is actually your a squared, and this is your b squared, so I could flip it around. That's important when you graph things. Over 1 equals 1. And there you have it.